This is a tutorial on solving inequalities. Let's look at the addition property of inequality. If we let A, B, and C be real numbers, then if A is greater than B and A plus C is greater than B plus C, if A is less than B, then A plus C is less than B plus C. This property is also true for the greater than or equal to and the less than or equal to signs. Here's an example. If we let A be 5, B equals 4, and C equals 3, we know that 5 is greater than 4, so 5 plus 3 is greater than 4 plus 3. Problem 1. X minus 15 is greater than negative 12. What we want to do is add 15 to both sides, which gives us x is greater than 3. And the solution of x greater than 3 are all real numbers greater than 3. The subtraction property of inequality. Let A be greater than B, then A minus C is greater than B minus C. And if A is greater than B, then A minus C is greater than B minus C. This property is also true for the greater than and the less than signs. Example 1. Let A equals a negative 3, B be 5, and C equals 2. We know that negative 3 is less than 5, so negative 3 minus negative 2 is less than 5 minus 2. Let's look at problem 2. T plus 6 is greater than negative 4. Well, we would need to subtract 6 from both sides. And when we subtract 6 from both sides, we get T equals negative 10. Let's look at the multiplication property of inequality. Let A, B, and C be real numbers, with C being greater than 0. If A is greater than B, then AC is greater than BC. If A is less than C, then AC is less than BC. Let A, B, C be real numbers, with C being less than 0. If A is greater than B, then AC is less than BC. If A is less than B, then AC is greater than BC. The properties are also true for the inequality using the greater than or equal to and the less than or equal to signs. Example 1. X over 3 is less than negative 2. If we multiply each side by 3, x then is less than negative 6. Example 2 to the right. Multiplying by a negative number. Negative 3/4 x is greater than or equal to 3. If we multiply both sides by the reciprocal of a negative 4/3, it reverses the inequality statement. So, W is less than or equal to a negative 4, which makes the statement true. Let's look at the division property of inequality. Let A, B, and C be real numbers, with C being greater than 0. If A is greater than B, then A divided by C is greater than B divided by C. If A is less than B, then A divided by C is less than B divided by C. Example: 6 is greater than 3, so 6 divided by 3 is greater than 3 divided by 3. 9 is less than 12, so 9 divided by 3 is less than 12 divided by 3. Let's look at the division property of inequality. Here's an example. W divided by 6 is less than or equal to 1. To reverse the operation, we must multiply both sides by 6. Therefore, W is less than or equal to 6. Example 2. Dividing by a negative number. Negative 9y is less than or equal to 63. Well, if we divide by 9 by both sides, we get y is greater than or equal to negative 7. Remember, when multiplying and dividing by a negative number, you always switch the inequality.